This research uses a functional data analysis approach to model COVID-19 cases across US cities. Now, a common narrative we've heard many times at this point is to flatten the curve, that is, to reduce the number of cases of COVID-19 over time. Now, as you can see in this picture, there's been substantial variability across locations in regards to how their curves look. Mainly, there's two sources of variability that arise. The amplitude, which has to do with the vertical heights or severity of the peaks, and phase, which has to do with the timing or horizontal shifts of these peaks. Now, using functional data analysis, we can treat each curve as its own data object and treat it as a smooth function. That way, we can extract the amplitude and phase components. And by doing so, this allows us to model and better visualize these curves. Now, our goal was to extract these two components in the context of the unobserved data, given that the pandemic is still ongoing. And for example, by mid-June in Houston, we still hadn't seen the full peak of the number of cases in Houston yet. And yet we still want to be able to extract the phase and amplitude functions out of this. Now, we were able to do so using estimation and curve fitting through a combination of functional principal components analysis and clustering. This allowed us to get the warping functions, as you can see in the top left. The warping functions tell us about the variations in the timing of the peaks. And in the bottom left, we get the amplitude functions as well, which tells us about the vertical heights of these peaks, which is essentially the aligned version of those curves you saw in the previous slide. And these amplitude functions are much more informative now, as you can see in the bottom left, because they have much less variability over time, and their curves are much more informative and reflective of what an actual outbreak might look like in a given location. Now, these warping functions are also highly informative as well because they tell us about the timings. And a lot of focus has been mainly on the severity of these outbreaks, but this FDA framework provides two improvements to COVID-19 modeling, which is allowing for improved analysis of the amplitude, but also joint analysis and modeling of the phase components. So we can add covariates like social distancing metrics and demographics to understand how these factors affect not only the shape, but also the severity and timing of these curves. And more work needs to be done on understanding the properties of these warping functions so that we can properly include them and interpret them in our models.